มาแล้วจ้าเด็กๆครูยกตัวอย่างนะ Okay, welcome back again everyone. So this is just to train you to be able to use the equation, that's all. For example, if we have rectangular cross section with the width of the cross section 2 meter, and when we have q equal to 8 cubic meter per second, so if we want to have the critical flow occur, but it will never occur in horizontal bed, but if critical flow is occur, then what is the value of water depth of critical flow? Just use this one is properties of critical flow, right? We already proved it, this one. So that we just substitute the value of Q, and then we can get the value of Y. That is the depth, that's all. And if we want to know what is the velocity, we just use the second properties and then we got it. And then in this case, the energy is this one. Just substitute the value of Y. That's all. Just practice to use this equation, this relationship. Okay. This one, if we want to compute transition flow, what happened? So, in the case that we have a rectangular cross section like this, and if we know upstream condition, that is, if the water depth of upstream is 1.5, if the velocity of upstream cross section is 0.9 meter per second, and if we have a change in riverbed like this, delta z is equal to 15 centimeter. Question is, what is the value of y2? Practice to use the change of water level equation. So, first, we have to check the condition of upstream. What happened? So, if we substitute the value of V, 0.9, and substitute the value of Y, 1.5, we will get the value of root number, which will be less than 1. So it means that this is subcritical flow. Okay? So now the condition is that if we assuming that there is no energy loss, then we use Bernoulli equation. This equation, Bernoulli equation, y1 plus v1 square over 2g, actually plus z1, right? Equal to y2 plus v square over 2g plus delta z. This value on your right hand side is unknown. What we want to determine? Y2. And we have to put this value in terms of y2. Then we will have only one unknown, because at the y1, this is 0 datum, y1 is known, 1.5, v1 is known, 0.9. Then what we have here? We have 1.39. And in this case, we have to rearrange E2 in terms of Y, right? So we use the continuity equation, Q1 equal to Q2, V1 A1 equal to V2 A2. Then we can use this one, V2, in terms of Y1 and Y2. We substitute this one into the first equation. Finally, what we get? Only y2 that is unknown, only y2. So we have to trial and error to have the value of y2. We have two value of y2, that is 1.3 and 0.2. Which one is correct? First, we reminding what we have already studied last time. EY curve. Small q is constant, right? Then we can use this one. At the upstream condition, it is 1.5 and it is subcritical flow, right? Subcritical flow. Then this is E1. Then we have delta Z. Because we already do like this, this is E1 equal to E2 plus delta Z. What do you want to know? Y2 is equal to E1 minus delta Z, right? So this is E1 minus delta Z. This is E2. At E2, you have two values. First one is 1.3. Another one is 0.25. Which one is correct? The first one. Because upstream is subcritical flow. Then this one should be subcritical flow, right? So in this case, you can see here, this is Y2 is 1.3. So totally this is 1.45. Here is 1.5. So according to your eyes, you can see water level here is decreasing with the value of delta y equal to 0.05, right? So this is what happened. Okay, now you can do like this. Okay? Another one. I will ask you. Think about this and try to calculate. If I want this section to be critical flow, and this one the same, 1.5, this is the same, 0.9. But I want this cross section to be critical flow. My equation is, what is the value of delta Z? What does it mean? It means that if I want this one to be critical flow, this is YC. What is the value of delta Z to make this one critical flow? Okay? Everyone okay? Try to think about this and try to calculate. Let me know. Okay. This is, I just to remind you you can determine like then we can determine x1, x2, x3, right? This is the review your mathematics when you study mathematics. Okay, this is what we already said. Now, let's see. If you see another cross section that is natural cross section in the natural river, this is a regular shape. And if you see the cross section like this, which is trapezoidal cross section, oh, how can we determine YC? because what we already studied, it is in the case of rectangular cross-section, right? Okay, now I introduce general formula which can be used for any cross-section. Same. We beginning with this one. This is the definition of specific energy, right? From definition of specific energy. Then E equal to V square over 2G, right? You change V in term of Q. That's all. And then at this point, EY curve, this is minimum. So in this case, at this point, dE by dy is equal to 0, right? So this one is equal to 0. You differentiate this one. And at E minimum, dE by dy will be equal to 0. And then, let's see, only this one, dA by dy. If it is natural river irregular cross section, then if this one is y depth and delta y is here, delta y, so delta a, change in delta a is this one b multiplied with delta y, right? So you rearrange the term. So this is dA by dy. B, it's A equal to by, right? So B equal to A over y. So that we differentiate and change this one. So this is what? dA by dy will be equal to B, right? So dA by dy equal to B. So that this one is B and is equal to 0. And then the first term, we try to make it into fruit number. Put it as V square. Then this is V square and G and A. Then with this one, we change B to be A over B like this. And this term is V. And then G is the same. So it means that dE by dy equal to 1 minus fruit number squared. Alright? So it means that this one we can substitute here. dE by dy equal to 1 minus fruit number square. Okay? So with this one, what we have, like a properties of critical flow for any cross section, same. If this one is equal to 0, then it means that rearrange the term. We got this one as the property of flow. So property of critical flow similar to rectangular cross section. Change only this one. DC is YC. Okay? And if you want to know Q, Q will be Q equal to VA. Just multiply A. Okay. Looking at this case, if you have this kind of cross section, it is trapezoidal cross section. So this one, you will have this one as a depth of flow when it is critical. But since fruit number equal to V over square root GD, and D is what? D is A over B. This is B. B. So A over B in this case, depth, hydraulic depth will be here. not depth of water. Just to remind you, just to show you that in case of another cross section, which is not rectangular cross section, hydraulic depth is not equal to water depth. Y is water depth, but D is hydraulic depth, something like an average depth. Okay, like this, just to remind you like this. Let's see. If you want to determine what is the depth of water when we have a critical flow occur in another cross section which is not rectangular cross section. Okay, I come back to curve again. This is the graph that we can find in Handbook of Design to help us to determine depth of flow in case that we have rectangular, in case we have circular and trapezoidal cross section, not rectangular. We can determine by using the graph. But if we don't want to use this kind of graph, we can also calculate by hand. Let's see example which we calculate by hand first. Okay? Okay, this one. I tell you like this. Another thing that I want to tell you here. I teach you like this. We will see this one in another chapter. But I tell you now, when we go to that chapter, we will skip this part. I will introduce you. Best hydraulic cross section. Oh, what is the meaning of base hydraulic cross section? When you study in structural engineering, we study that when we design, no? RC design, we have the load. We have to design cross section of this beam. First, we have to check whether bending moment diagram is okay or not, right? Secondly, we have to check whether shear diagram, shear is okay or not. Then we have this cross section. First, we try the value of the B, and then we reinforce, right? The concrete. This is the design. Same. But this is hydraulic cross-section, not beam cross-section. For definition of base hydraulic cross-section is the cross-section where we have the smallest resistance of flow. Resistance of flow occur from what? When the flow like this and water level like this, you will have a resistance of flow here because particle of water touching here like a shear force. And this one, all that I draw in pink color, we call it as P or wetted perimeter. Another meaning is the place where water touch, and it's the place where water has the resistance, right? Because it's touching here. This is the technical term, wetted perimeter. Okay, so we will obtain the smallest resistance of flow when we have smallest wetted perimeter. For a given A cross-section area. Suppose that you have this one You have this one. You have this one. And you have this one. A1 equal to A2 equal to A3 and equal to A4. For a given A is the same. Which cross section give you smallest perimeter? We can prove, mathematically speaking, we can prove, and the answer is this one. That's why when we work, we design our drainage system. Let the flow in circular pipe, because flow in pipe, but flow is why? But flow เอ้ากูไปอยู่หน้าไหนแล้วเนี่ย but flow is not full water touching atmospheric pressure, so it is open channel flow. This is open channel flow, and this flow gave the best hydraulic cross section. But in real open channel flow, you can notice that when you have a irrigation canal, when you have a canal that designed to deliver water, normally it is not this one because it's hard to construct. Then what happened? The second base, we can prove, mathematically speaking, we can prove, and we found that this is the second base. That's why you can see that almost all of the time you will see the cross section in terms of trapezoidal cross section, right? But again, more than that, trapezoidal cross section is not the same, right? You can have like this, or you can have like this, not the same, but it is also trapezoidal cross section. We already proved, mathematically speaking, that the best trapezoidal cross section which give smallest value of wetted perimeter is half of hexagonal, with this one hexagonal, and this one is 60 degree. This is the base for trapezoidal cross section. Moreover, more than this, in reality, in practice, when you go to work, suppose you have to dig irrigation canal, deliver water to farmers for 100 kilometers, and you have no budget, just digging it. So in that case, you have to dig by using soil, natural soil. You have to do boring, and then test by doing sieve analysis, right? Sieve analysis to find the distribution of grain size, to find how many sand, how many silt, how many clay, what is the median value of your grain size distribution. And with these kinds of things, when you go to handbook soil mechanic, you will find what is the soil type. And with that one, from experiment, and it will appear in the handbook of the design, it suggests the appropriate size slope. 1/m, right? That is the best thing that you can do. That is the best hydraulic section that you can do in practice. Okay, so what I want to tell you is that first, the definition of base hydraulic cross section is what? Secondly, mathematically speaking, this half of the circle is the base one. Sometimes we cannot construct, so we use the second base, that is the half of hexagonal with this one equal. This side is equal this side is equal this side, and this one is 60 degree. But in reality, if you have to construct the canal on the earth natural clay, you have also to going back to the knowledge that you know from soil mechanics, strength of soil. You have to find boring to do the boring, taste the sample of your soil, and doing seep analysis to find the distribution of the grain. And then you will find the soil type and find the appropriate side slope that make your slope stable, slope stability, right? Okay, going back here. When we design our cross section like circular or design like a trapezoidal, we can determine the value of YC according to the graph that is in the handbook. But first, before using this graph, which is in the handbook, I show you how can we determine it by using by hand. This is example using the concept. Example, in case that you have trapezoidal cross section with this dimension, when we have trapezoidal cross section, notation that we use, small b is the width of the canal at the riverbed, and capital B is the width of your cross section at water surface, and 1 over m is your side slope. Okay, this is general notation that we use when we draw a cross section of trapezoidal cross section. In this case, m is given equal to 2. Small b is given equal to 2 again. Then with this kind of thing, you can find capital B, right? Because it's a summation of B plus 2my here, right? B equal to small b plus 2my, right? So in this case, we can find this one. So go back to definition. We already derived analytical properties of critical flow, and we obtain this formula, right? Relationship between velocity and the depth. This is hydraulic depth, right? It's coming from when fruit number is equal to 1, right? And what we know this one? We know that this one V is Q over A. And this one G is the same. Definition of hydraulic depth is A over B. So which value that is known? Q. Dimension is known except Y. Only one unknown left except Y. So only one unknown left here. So you can determine Y from the above equation. But you notice you have many value of Y because this is order Y to the power 6, right? So you can have 6 value of Y. 1, 2, 3, 4, 5, 6. But this one is correct. It means that you can use this graph to help you to know the value of Y. We have 3 cases, okay, using this graph. The first one, this one, we will determine the term like this. This is log graph. We have this one x-axis and we have this one y-axis. The first one here, we have what is given when we design. This one, suppose when we design, we want to design yc is this value is given in case of circular cross section, and in case of trapezoidal cross section, this is y is known. B is known. This is in case of trapezoidal cross section, and M is known. This is in case of trapezoidal cross section, and D is known. This is in case of circular cross section. Okay, this is simple. If all of this given, what is the value of Q? This is just straightforward. You can just substitute everything in the formula and you can get this value. No need to use the graph. Okay, but if you want to use the graph, no problem. You can use this graph because from the given value you determine these two terms. First term, second term. This first term myc is 1, is here. And then you use this one and you find which one is represent your trapezoidal cross section. myc. When this one is suppose this one is trapezoidal cross section, then you will get this value. And this value x-axis is what? X-axis is this one, x-axis is this term. Suppose you got this value is equal to 80. Suppose it's 80. Known, right? This one is 80. Then the term of x-axis. We have two terms. First term, in case of trapezoidal, is Q M over B square root GB. This one is known, right? Equal to 80. Value that is unknown is only Q. Or the other value, M is known, B is known, B is known. So only Q that is unknown. That's all. In case of circular, you determine YC over D, and then circular. Then you find this one. Suppose this is 600. Then this 600 equal to which term? This term. Why? This term. C is 600. We read from the graph. And D is known. D is known. Only one unknown is Q. Then you determine Q. Okay? The second one. After this one, I finish, okay? A little bit more. We nearly finished today. If another case, we have design Q, we want to design Q. We want our cross section to have this amount of water, design Q. And when we design, suppose it is trapezoidal cross section, we design with our B like this. We want our cross section have the width at the riverbed small b like this. We know 1 per m. We know of this balloon is known. What we have to know is what is the value of y. If critical flow occur, what is the value of y? Okay, so in this case, all of this term is known. Q is known.ผิดอัน. Q is known. M is known. B is known. B is known. Then we go to trapezoidal cross section. And then we can determine this value. This value, suppose it is 20. 20 is known. Then the 20 is what? Is M, Y, C, and B. So B is known, M is known. Only one unknown. That is Y can be determined. In case of circular cross-section, Q, design is known. D is known, we decide. The unknown is if critical flow occur, what is the value of YC? So in this case, Q is known. D is known, D is known, then all of this value is known. Then we go to the circle one. And then we determine, we can read from this graph. Suppose K equal to 50, then 50 equal to YC divided by D. D is known, then YC can be determined, right? By using this graph. Last one, and then we finish. In this case, we will use the graph that is inside here. We read this one inside, and the graph that we use here, we will use dot. We will use dot. Okay, two things. What is the thing that is known in this case? Suppose we know the value of YC, M, Q. What we want to know, what is the value of B? What is the value of D? This time, what we determine, we have to determine the x-axis. Okay, x-axis, we can determine all of the value of x-axis. Suppose it is trapezoidal. We use dot. This line, and then go to read this value here. And then if it is trapezoidal, you get this value. All value is known except B. M is known, B is known. Except B, then you can determine B. However, in case of the circle, you use dot here. And then you determine x-axis. And then you can determine y, which is this one. And this value is YC over D. YC is known, then you can determine D. So you can use in every case. Okay? That's all for today. Any questions?
อาจารย์ครับใช้เส้นทึบหรือเส้นปะนะครับ
In this case, dot line. Last case, dot. And dot line. And inside, read inside.
ใช้เส้นปะใช่ไหมครับอาจารย์
Yes, this one, dot line. And the value you read inside here. Okay? Example. That's all. Okay? Everyone is okay? More questions? Next time I show you the application. Okay ไหมคะ Okay? No? Thank you everyone. Thank you all students attending the class patiently with me. Thank you very much. Okay, I send you this one again in line. But after I finish all, I will post it in MS Team. Okay, and then next time we continue a little bit more and beginning the next chapter, momentum equation. โอเคนะคะบายบายไหมลูก
ขอบคุณครับอาจารย์สวัสดีค
ส
รั
วัสดี
บ
ค่ะ
สวัสดี
สวัสดีค
ค่ะ
รับ
เจค่ะ
บายบายเลิกสวัสดีค่ะ
สวัสดีค่ะ
สวัสดีเลิกบายบาย